of the water. That would be our
Or
current.
is it current? Current.
Exactly. So a current is created when the water, the warm water, rises, forcing cooler water or more dense water to sink. All right. So current is used as a term to use as a term to describe the flow of the water. Right. Just like in electricity, current is used to describe the flow of charges. Just like in the river, current is used to describe the flow, right? Simple stuff for this. All right, so move on now to radiation. And we said that radiation is heat transfer through space. All right, so for other types of transfer, we saw that liquid and gas are fluids, right? And therefore, convection requires Convection requires molecules or particles to occur. So convection requires particles, and also conduction also requires particles. All right, so convection requires particles, con convection requires particles, conduction requires particles, right? But radiation, on the other hand, doesn't require particles. All right, so radiation is heat transfer through space by electromagnetic waves. So unlike conduction and convection, radiation can occur in empty space, right? As well as in solids, liquids, and gas. So that's the difference between radiation, right? Radiation can penetrate all of these, or radiation can cause heat transfer to all of these, right? But it just doesn't require molecules to flow or to transfer heat, but it can basically penetrate anything. All right, solids, liquid, and gas. So waves such as visible light, infrared, and ultraviolet light are some examples of radiation. All
So
right,
there's radiation, ultraviolet rays, everything that affect the skin.
everything has to do what?
It not affect the skin.
Right. So you have some of the radiation that has. That's a good point. Some of the radiation, some of them have too much of a wavelength. The wavelengths are too high, right? That they can affect the skin. Affect the skin. That's why, um, in some parts of the summer, right, they encourage you to wear sunscreen to protect you from some of those ultraviolet rays. All right, ultraviolet rays coming straight from the sun. And we'll talk more about the atmosphere and how it actually works. But before we do that, um, we can talk about um, these are just some examples of radiation, right? Heat transfer, fire to the hand, to keep the meat warm, and the temperature
Sir,
inside the house. All right, go ahead, Darius.
sir, um, dangerous.
All right, you have, as I said, you have different. All right, let me go and get that now. Let me go and get that particular picture. Give me a second. All right, so some of them are dangerous, right? Some of them you don't want to come in contact with. Yeah, some of them you don't want to come in contact with, but some of them are good. For example, visible light. Visible light should be good for your body, not too much, right? But ultraviolet rays, definitely too much ultraviolet rays are not good for your skin. Electromagnetic spectrum. Let me see what pops up here. Yeah, so some of these are not good, right? While some of them they they're still not good, but you won't be affected if you come in contact with them. So I'm just putting that on the slide now. All right, we're not going too deep into it, but I'll just introduce it to you for the future. Let me see here. So as I said, that's why sunscreen is so important. For example, you're going to the beach, you're not used to so much UV rays, so therefore they encourage you to wear sunscreen. If you're going to the beach, right? If you're going to spend long hours inside the sun or outside in the sun, they encourage you to wear sunscreen to protect your skin from burns and so forth, and even from skin cancer. All right, so here it is. All right, so the visible light, if you can observe, it is a small section here. So you have many different wavelengths of light, or this is the electromagnetic spectrum. Okay. So these waves, they're able to go from place to place, or to be transmitted, right, through space without any form of resistance. They're able to do that without any form of particles as well. So this section here is called the visible light section. You have infrared here, you have UV light here, and then this is where it gets dangerous. This is where it gets very dangerous. UV light, X-rays, right, gamma rays. All right, so these particular ones, you don't want to come in contact with them for too long, right? If you're going to do X-rays at the doctor, there are some control situations. There are some things that you're not getting the full power of the X-ray. That's what I'm trying to say here, right? So these are very high energy. Again?
Did you say the music X-ray machine and that danger?
Yeah, so they control it, right? You can't come in contact with the full force of the X-ray, right? You are only able to manage, you're barely able to manage visible light, much less UV light straight from the sun, right? You're not able to manage gamma rays and X-rays, all right? Now, we'll go to transfer of thermal energy, and do we know what this is?
Solar heater.
Right, so
Our
this is
solar system.
a solar water heater, right? And it's essentially does what exactly?
Heat the water with your pipe.
All right, so it heats the water, but how exactly does it heat the water? All right, so the sunlight hits this, and then this is transferred to this, right? To the tank here.
Yeah.
Okay.
What if not, like, place back of one?
Go again.
You place like back of 1 week or so.
But the place is no sun for a week.
Yeah.
Yeah, I personally have one of these. It's not this particular type though, but if the sun doesn't shine, it's going to get cold. Right, the one that I have is efficient. Even if there could be a little bit of sun and it's still warm, but for this one is not so efficient. It will be cold.
You know, like a quality heat storage.
Collect if it's stored. I didn't hear that.
No, collect the heat. And
Yeah.
store the heat.
Oh no, that's what the tank is for, right? You don't have that's the tank is used to store the heated water, right? And when you're ready for it, you turn on the pipe and it comes from the tank, right? But if there's no sun for a couple of weeks, or say a hurricane, hurricane is passing through, rain, right? You're not going to get any hot water, right? You'd have to have a backup hot water system from the um, electricity, all right? So essentially, as we said, the sun comes in contact with our collectors. We call these collectors, right? And essentially, the heated water, as always, this is our tank. The heated water always goes to the top. All right. Remember that hot water is less dense. Realize why I'm stressing this? Hot water is less dense. Right? So hot water goes at the top and cold water goes down to the bottom. And of course, the pipe would be somewhere here. And then you connect it to your system. All right. Oh, we know what this is? This is familiar?
A thermos, sir.
Right, so this is called a thermos. This is specifically designed to do what exactly?
Keep the water cool or hot.
All right, so if you have cold
Sir,
water, you want to
trap thing. Yeah, like trap heat.
exactly. Right, so if you have cold water here, you would want to keep it cold, or if you have hot water or any form of hot beverage or soup or whatever, it will keep it hot. Right, so that means that you would have it is specifically designed for this purpose. So you have the plastic. The plastic is a conductor or a insulator. All right, so we start at the top. This is an insulator, so it helps in stopping the heat transfer out of, because this, of course, is the most important section. Why? Because heat would want to come through here, right? That's where the heat will usually go for a pot, or let's say a cup of coffee that we saw earlier. Because it was open, heat was able to leave, but that's why the plastic stopper is here, right? Next section is our vacuum, right? Is heat able to go through a vacuum?
No, it does.
Exactly. So the vacuum would play the role of also an insulator, right? So the vacuum would play a role of an insulator as well. And we have question.
This in a Google Classroom because we just come in. I mean, not really understand what go.
Yeah, I'll post this in Google
Man,
Classroom.
direct time.
All right, I'll post it in Google Classroom with the video as well. All right. Now, these are thin silvered walls of glass. Now, the first one, let's look on the word silvered, right? Silvered. What does that suggest? It is dull or shiny.
It does, sir.
Let's go again. Silver, right?
Shiny, sir.
Right. So that's it is of course shiny, right? So therefore,
Silver.
yeah. All right.
So you tell me saying a different silver
More than likely,
with that color.
More than likely, it is shiny. All right, let's not debate about this. All right, you can go on Google and type in silver. So the silver, which one attracts more heat, or which one traps more heat? Dull or shiny objects? Which one traps heat?
Shiny objects. Shiny objects like what what metal, you can show them one metal on the ground. So now go heaty and it hot.
Shiny objects traps more heat?
No, dull.
Exactly. So dull objects traps more heat. Now shiny objects, right? They will reflect heat. So dull traps heat and shiny reflects heat, right? Or reflects.
Yes, sir.
Exactly.
Like
so therefore the the fact that it's silvered and shiny, it would reflect the heat, so it would remain in the container. So these are just some mechanisms that are used to keep this particular thing hot. All right, and let's look on right. So the corks, this is just for safety, just in case it falls. The cork is used to hold the flask in place, right? If you break the flask, it is no longer useful. All right, you more than likely have to throw it away. All right, and of course the outside is also shiny, right? This section is also shiny, which should reflect heat, shiny as well. All right, so are we clear on the thermos?
Yeah.
All right. All right, the last one is our greenhouse effect. All right, we can look on the greenhouse effect. Now, the sun produces radiation, and usually what happens is that you have short waves hitting the ground, right? So you have short waves hitting the ground, right? And then you have longer waves, long waves leaving, right? Long waves leaving from the short waves. So this is our sun here, and it is shining, right? You have short waves coming in and long waves. Now what this does is short waves come through the glass here, and it hits the ground and the other plants in here, right? Essentially it hits it, and what happens is that long waves are therefore trapped because of the glass.
Grocery glass can direct heat.
Go again?
The glass can direct heat.
Right, so the glasses essentially do the job of trapping the heat, because long waves are not able, if they find it very hard to break or to penetrate glass. All right, so you find that the wavelength of the original radiation, the wavelength increases, and because the wavelength increases, it doesn't have enough energy, right? Because it was remember that it was absorbed by the ground and also the plants. When it loses energy because it's absorbed by the plants, right? And then when it's being emitted or released, it comes out as long waves. These longer waves I find it very, very difficult, much more difficult to penetrate the glass. So therefore the heat is trapped inside. This would help in the growth of the plants, because the plants need heat, and this is especially useful in much colder environments, right? This is designed for much colder environments during the winter and so forth, when they don't have much heat or energy from the sun to grow these plants. So you find that plants don't grow that much when the place is cold. All right, so that's why this was designed to really help in the growth of plants, and persons can still farm in these times. All right, so is that clear on the greenhouse?
Yes, sir.
All right. Anyone not clear? All right. So yeah, the same thing as we said. The glass breaks through the roof, right? It goes to the soil being heated, right? Soil being heated by sunlight and also the plants, and it comes out as much longer waves. All right, it comes out and therefore it is trapped. Therefore, it is trapped inside, and essentially it gets hotter and hotter. And I believe that is it for radiation. All right, so we'll pause here and then come back. Let's pause here for now and then return. Join us as quickly as possible. All right.
All right, sir.